Well, ladies and gentlemen, good afternoon and welcome back to the SMPTE stage at MPTS. I'm John Ellerton, Chair of SMPTE UK and Director of Technical Sales at EVERT, the UK and Western Europe. We've got a packed afternoon for you, beginning with Peter Brightwell and Willem Vermost, who are going to talk all about DMF and MXL, building the next generation of production architectures. Take it away.
We have moved into a new era. Our audiences are migrating towards streaming. We have to move there with them. What that means is these big legacy estates where we have high investment in fixed kit no longer serves the type of output that we have to create.
So the Dynamic Media Facility, or DMF for short, is about a fully software-defined production and broadcast infrastructure. So it's all about being dynamic, interoperable, and automated.
Dynamic Media Facility brings in modular software workflows with cloud infrastructure where we can scale up or scale down. In the long run, there will be significant reduction in costs.
And so we move away from this broad brush compromise model and towards technology that really serves our content creators.
A key ingredient of the Dynamic Media Facility is what we're calling the Media Exchange Layer, or MXL.
There's a big buzz around MXL. It allows anybody to just send uncompressed, high-quality video effectively without latency from one place to another. And the problem is that just hasn't been possible until to date.
DMF and MXL are going to have a huge impact on how broadcast and production infrastructure happen in the future as we move to an all-software, cloud-fit future.
So, good afternoon, everybody. I hope you are having a good MPTS and just being waved at here. So let's see how loud we can go. Is that good enough? Lovely, thank you. So my name is Peter Brightwell. I'm lead engineer at BBC R&D, and with me is Willem Vermost, who's senior media technology architect at EBU. And if you were here earlier today listening to Andy Rayner, you would have heard quite a few plugs for this session. We're going to be talking about the next generation of production architectures, and in particular, these mysterious acronyms, DMF and MXL. So let's see if these slides work. Yes, they do. So as we saw on the video just now, and if you want to see a fuller version of that video, look on the BBC R&D website. And thank you to everybody who helped make that. We have some of those in the audience here, so thanks, guys. Our industry is becoming software and cloud native, and as we are moving to a state where basically everything becomes software. You go around here, you'll see loads of software at MPTS. If you've been to IBC or NAB, loads of software there. You'll see these platforms. There's some examples of the type. This is not all of them, but some examples of companies. Many of them are here producing software platforms to do live production. And there's a sort of vision of this is what a facility might be in the future. So we talked about this Willem and I talked about this in the past. We're going to give you an update on what's happening on the DMF. So take it away.
So good morning, everyone, or good afternoon. Thank you for being here. So my name is Willem. I work with the EBU, and I think a few years ago, already when I was co-chairing the program together with Pete, we were having a small vision of how we could produce more efficient in the future. And actually the Dynamic Media Facility, so we produced a document at the EBU, that's what we do. This is actually a vision of how we should produce more efficient in the future. So we're looking whether it be on-premise or whether it be in the cloud, maybe scaling up, but mostly scaling down as well for some of the things. And what we did find out, and you can probably go to the next slide already, that most of the things that we did in the past, we just installed something up to the peak. Whether it be the elections or whether it be a huge sports event, we designed for peak, and that's completely not efficient. There's even a report out there, I believe it's from the colleagues of Skyline. They claim that 90% of the time, your boxes in your facility are just not doing a thing. Meaning 10%, that's not what we call efficient. So how can we change this? And looking at this and looking at the industry, we thought, well, maybe the time is right. I'll make a small pun of the PTP colleagues who know PTP. You know, there's an epoch of PTP called 1970. Well, the epoch of going to live IP, that's probably the JTNM reference architecture in 2015. Now, a few years later down the road, there was a paper from Richard Cartwright and Brad Gilmer to talk about the agile media blueprint. It didn't take up, but actually the ideas were there. But now, if we look at the industry, we have CPUs, we have GPUs available at our fingertips, which are so powerful. We have all these virtualization techniques, like containerization. We have, you can just run through your Docker and get to the GPU. It's just powerful enough. Maybe with the current technology, we can run half of your facility today. So that was the thinking. So we created a document with our vision called the Dynamic Media Facility. And this is truly where all the value lies, we think. So we think that with this technology, we can just spin up a workflow on the fly. And maybe, if possible, we can do multiple productions on the fly, because there are multiple smaller productions these days as well, because we need to serve all the outlets. You know, with media technology these days, we need to be there on YouTube, maybe on our digital outlet, on live television. We just need to make sure that we're serving all our audiences, young people, elderly people, in the middle. It's hard to get there. So if we need to produce as much content, we need to be flexible in our infrastructure. That's truly the idea. So if people talking about digital transformation, we are now talking about how to transform our production facility. So we try to decouple all these things a little bit, right? How can we achieve this? Well, we thought about actually a workflow. And how should a workflow look like? Well, in our document, we described something, well, maybe a life cycle.
Should we do this? Should we talk about the life cycle?
Yeah. So we described the life cycle, and actually the life cycle is what you do today, right? You go out and, yeah, let the life cycle flow, Pete. Just click it away. This is what you do today with a traditional facility, right? You think about what your production is going to be, you design it, you plan it, you provision it. Instead of provision hardware, you provision people, you provision cameras, you rent them out on the market, you rent your EVS servers, your OB truck, whatever it is. All of this is not new. But now in the world where we're going into software and we're going to run this on a cluster, of course, this needs to be attached to a stack of technology. So we're looking in our vision paper from the business case towards the life cycle and now to the stack of technology. Yeah, so Pete, this is what you want to talk about.
So let's move on to the DMF technology stack. Now, you may have seen presentations. Just a quick show of hands. How many people have seen this before? So we are quite a lot of experts here. Have you seen the latest version that has media exchange in and orchestration in? It's looking good. It's looking good. So yeah, so we don't have to say everything. Now, from where I'm sitting, everything looks grey on that screen. So I think MPTS should get some better screens. But if I remember this correctly, which I do, then the top three of those layers are green, and the reason they are green is because that's where we want the industry to concentrate on. What we don't want the industry is to reinvent the IT and IP stacks that are in blue. So the DMF layered model is about separation of concerns, making sure that you're working on, you have good interfaces between the different layers, which allows us to, as users, to go and pick the best of breed and not say, for instance, have to go and buy a particular server because that's what a particular media application requires, which often has been the case in the past. But I'm pleased to say that things are moving on a bit, and due to techniques such as virtualization, containerization, and, well, orchestration, we'll come to that, things are looking a little bit more rosy. Now, you had a little sneak preview there of media exchange being highlighted there. So media exchange is one thing that is an absolute pressing priority for the industry. Why? Because everything so far has been designed assuming you've got two physical boxes connected together via some sort of niche cable. So in the past, this would have been SDI or XLR cable. We've moved on a little bit since then. We've got ST2110. That is a sort of dedicated IP. It's a great piece of work there. Mm-hmm. But what it wasn't done was designed for sort of real-time, faster than real-time, high-speed exchange between software applications running in a...
It's designed to be transport efficient, I would say. It's very transport efficient. But then we realized if we move this into a compute world, we need to be not transport efficient, but compute efficient.
Yes.
And asynchronous.
Exactly.
Yeah.
So this slide here shows... Well, okay, it's missing some bits, but I'm sure you can work them out. So in the MXL model, basically it is a shared memory interchange between these things we call media functions. A media function is just a unit of video, audio, data processing. And by sharing the video and the audio and the data in an agreed way, we can do that using shared memory within a host, or we can use techniques such as RDMA, remote direct memory access, or elastic fabric adapter, or some sort of fabric connection. And modern systems will provide huge speed, so we can easily get multi-10 gigabits per second between processes running on different machines. So this is definitely going to be the way forward. But it does lead to some other challenges, of course. And one of those challenges is that a lot of people in the industry have been trying this already, and we need a way of this happening in a consistent and interoperable way. So
there's a small example here, because maybe it's not completely clear for those who don't have a visual yet in their mind, or didn't connect to all what we've said in the past. So it's not a real picture here. On the left-hand side, these days 2110 is big in your facility. If you're already on 2110, it's not going to disappear, right? 2110 will be out there, and this is how you connect into your cluster. So if you're now thinking about, let's dip our toes into MXL and all these cluster stuff, you start to build a cluster on the side, and you connect all your 2110 kit to this cluster to bring those streams in. And maybe you use even SRT or WebRTC to look at the streams in that cluster. So there are different things that are transport efficient that you bring to the cluster and that you get from the cluster out. So point one. So on the left-hand side, I depicted the media functions, right? And as a function of your production, you could deploy.
Press the button.
Yeah. Well, hop. They're deployed, and now you can just deploy your workflow, right? So that's more or less the idea. If you want to split it up in smaller productions, you should be able to use the compute available at your fingertips for smaller productions, and scale out if you want to have one big productions like Olympics or elections again. Or maybe even, if the latency is okay, you can scale this cluster out into the cloud. Imagine graphics that are probably not so tight to real timing, at least most of the graphics. You can render this out in the cloud and bring it back. There are a few possibilities out there, right? So it's really this combination and this flexibility that we're looking at. In the pipe underneath, there's just an IP network. I drew That's MXL and RDMA, but it's just an IP network. On the left-hand side, 2110 running over the same IP network. So nothing new here. So you connect 2110 to the cluster, and off you go. Yep.
So we're going to talk about MXL for a little bit. We had a look to see, was anybody here, or is anybody in the industry prepared to open up what they had done already? Some people won't know how to think about it, but in the end, the best way forward was to work together on a clean field implementation, and we are doing it open source. We've worked with the Linux Foundation, so that's the organisation that's looks after the Linux kernel, USB drivers, all sorts of stuff, Kubernetes as well, and many, many other things. You will all have loads of devices on you that use Linux Foundation copyright in their source code. And it was about a year ago, was it? Something like that. We announced the intent to form the MXL project. So Willem and I are both heavily involved in that, along with Felix and my co-chair on the DMF group. And that is, and we have recently released the first version of the SDK. So it's an open source SDK. You don't have to. There's no strings attached really. It's just a simple Apache license. All the development happens in the open on GitHub. People can come along to the meetings that take the decisions as to what they want to do next. So this is quite an interesting approach. So we're basically doing the code, and then we're going to think about the standardization. So I do appreciate we are on the SMPTE stand here, so maybe people have got some questions lined up about approach to standardization, so we better think of some answers. We've had loads of companies involved, so that's not all of them, that's a lot of the main players. We have a logo, which I've seen quite a few instances of that logo around here. And as we were saying, version 1 was released early 2026. That's right, isn't it?
It was even dropped at Christmas Eve.
Yeah, it was Christmas Day. So,
yep.
So what does that give you? It lets you basically, it provides an SDK, a library, so you can exchange video and audio between applications that are running on a single host. So only on a single host, but the next version, v1.1, is making good progress, and that's going to add shared interchange using what's called the Fabrics API, and under the hood that uses a whole set of widely adopted and open approaches for fast memory exchange. We're also going to add some other tools to that on synchronization and provide GStreamer tools built in Rust, which is a great language for sort of modern developers. We have this little animation, which so MXL relies on the concept of a ring buffer, so an area memory where you're putting video in and out. So it allows basically multiple readers and multiple writers in theory. So there's some examples. Each of those could be a frame of video or a grain of video. As for those of you who came to Andy's talk earlier, he was talking about grains. So that is very much part of the MXL model. And I wasn't able to go to NAB myself, but Willem was there. And I think you saw 15 companies had MXL demonstrations.
Yeah, it's incredible. You just mentioned that we came live with the project June last year. We're almost June again. So in 1 year time, I saw 15 companies implementing the MXL SDK already. And there was a huge demo.
Yeah, there was an interoperability demo hosted on the AWS. If you stay later, then I can actually... So So what you're seeing here is of course, a recording from earlier, but this demonstration is still live, and if there's enough bandwidth at this event, we can do this demonstration live, but you'll have to come up at the end. But it will look like that. So, what's next, though, Willem? Willem.
Yeah, there was a bit of confusion, and that's what I tried to hammer out. A lot of abbreviations. We all love abbreviations in this industry, right? So DMF, that's the Dynamic Media Facility. That's the vision where we want to go. And it's a lot more than just MXL. MXL is just a small piece of the puzzle. But of course, once you move into compute, you need to be able to make sure that your resources are managed, that you can orchestrate all of these things, that the timing is good, because within the compute you're asynchronous. But if you want to watch it, of course, the video and the audio need to be synced again. So all of these things together form the vision. MXL is just a small part. So there are interoperability challenges that are solved, of course, with MXL.
Yes. Well, some of them are, but some aren't. So what we did is, in the EBU group, we took a poll really of what do users see as the most important things, and the ones that came up top were, how do you allow multiple media functions, we call them, you could call them applications, to running on the same cluster, compute cluster, to play fair and share their resource, share the memory, network, storage properly. Now, tools such as Kubernetes will help that happen, but you do have to have a sort of consistent way of saying, you know, I want a CPU that's, or a virtual CPU or a container box that is this big. I'm going to be sending video that is this format and so on. So that's what we're calling container resource management. And there's, just going back to that, so we've got the concept of a manifest as a way of describing. It's like a specification sheet for a piece of software. Next area is control systems. So how would you use a control system to connect together these particular functions or these particular applications? Now, obviously there are things such as NMOS, Catena, and many other protocols that have been used in this area in the past. None of that has really been aimed at these cases. So this is a bit of an open field here. And we're starting by looking at concentrating on connecting flows together. So flows being sequences of video or audio or data units, or grains as we call them. And the final one, and Andy Rayner talked about this quite a bit earlier, is about how do you synchronize something? You might come in via SDI, you might come in via ST2110, you might come in via SRT or so on. And that's all sort of running with linear time, it's working in a synchronous way. And then you take things apart, you work on them, potentially you're doing stuff in parallel because you've got a big cluster. How do you ensure that things go back together when they need to go back into linear time to be presented to people's eyes? So that's another area. So we have a new task force. Do you want to say something on the task force?
Yeah, something that we discovered while working on this vision document as EBU, even though we have 115 members soon, I should say. We're 113 now, but we get a very big country coming in a few months, so bear with us. So 115 members, great, but that's not great enough. You know, when you have a vision, as a customer you want something, but you need the full industry to be in on this. And with the EBU we thought, well, let's collaborate with the AMWA, because most of the vendors are actually part of AMWA, and I thought could be a good start of a joint task force to make this vision a reality. So another acronym, my apologies. We already had DMF, we had MXL, small piece of the puzzle, but now we introduce you JT, DMF, as the joint task force to work and to create this vision, and let's make it a reality.
Yep, so that's underway, and there's been three technical activities happening that correspond to what you're seeing on the screen. There is a business activity kicking off tomorrow, I think it is.
It is tomorrow, and actually the summary of those activities are here on this list.
Yes.
There's one extra one, and I think the proponent of the activity is in the room, and as a customer as well, because what are we as a customer if there's no vendor? And what are the vendors without a customer? So we need to clearly think about the business models as well. If we go into software, well, there will be licenses. And how will this work? Will it be tokens, jetons? How do you call it? Sometimes I even make a pun of it, and I would say, I feel like the bank. Like, as a customer, you need to have tokens with all these different companies. So we need to solve these type of things.
And also, what will be, how will vendors' business models just need to change when they're producing software and they can't rely on a proprietary BNC connector or something like that? So
yeah, and I'll flip it around again, because the customers need to change as well. Right? Moving from SDI to 2110, suddenly, oh, we need to learn IP. Yes, you'll need to learn IP, but now moving in this direction, we need to know something about Kubernetes and all these nice things. So there's a continuous change that we need to take into account as well.
Yeah. So Willem, we've got 4 minutes on that clock, so we better get a move on.
Okay.
One of the things that has come up as a challenge for the industry is what we can call orchestration. Now, orchestration means so many things, and that's because you can orchestrate lots of different parts of things. So it is a new vertical layer. So you can orchestrate your infrastructure, you can orchestrate your networks, you can orchestrate your containers, you can orchestrate your processes, you can orchestrate your workflows. So, and that always becomes confusing when you start talking about this. So one thing we're trying to do with this, the second version of the reference architecture here, is have a solid sort of model for orchestration. So in V2, we've got this new, I do like that, model that as we build up the layers, and we haven't got time to go through all these now, but we talk about relevant aspects of orchestration, how they relate to the layers and how they relate to those stages within the process workflow. And that does mean, when you propose to do a piece of work, you can sort of pinpoint where that is on this big board and know why it matters. You'll notice on the right, by the way, security. That's a super important thing, and that's another area that is heavily in discussion now in the JT DMF. So, what does this all mean for the future? Does this mean, are you going to have to think about MXL rather than putting in 2110? Absolutely not. So explain why.
Yeah, I think we were already clear on this, right? 2110 is here to stay, and you need a protocol that's transport efficient to get into a compute cluster and to get out to somewhere else. So it's not going to go away. If you think about an investment and you think, I'll skip this one, I'll go straight into DMF and MXL, nope. There will be 2110 around. So no stress into this. Actually, we've preempted the Q&A here, right?
We have a bit. But actually on that one, you need to make sure you design your networks so that they will do both
RDMA
and 2110 potentially. So, well, we got, so I guess the second area is what do we want to go single vendor, multi-vendor? I think what we're saying here is that we're giving you a toolbox so you can make those decisions according to what is best for your business. You mentioned licensing, so we don't need to do that again. And what are the skills that can be developed? These are like the questions that would normally be on a Slido, aren't they? Clearly, there's going to be some new skills. So,
this is a question that popped up during 2110 as well. What are the skills? Well, this is the new normal. Change is the new normal, and skilling up is the new normal. Or not skilling up, sorry, that sounds rude. It's changing your skills. That's probably what I should say. But maybe there are questions in the crowd. I saw there was a lovely lady having a mic as well to go around. Please, sir.
So I think we're on to questions, so let's go.
Yeah, so I'm going to pick up on some of the last things here, which is with all of this DMF and MXL, what will the impact of that be on the data distribution network? I mean, you need to get all of these uncompressed video feeds from where they are recorded, that could be an event somewhere, to where they are processed. So does that impose new requirements on the data network in terms of reach and latency and capacity and so on? Or can we bypass the OB truck if we can provide a good enough fiber infrastructure, or how do you see this?
I think this is it's related to the first of those questions that you don't. Maybe you're coming in compressed anyway. Just once it comes into what you might call a DMF or MXL area, we can then go as fast as possible. So we will have these hybrid cases for some time, and that is why we do have this work on joining up the timing.
Then there are things that won't disappear, and I even saw, we're out of time, so we should stop, but I'll answer this last question. There are things that don't disappear, and things are getting possible now, like even processing on site, just to make sure, if you're a commentator, you have a low latency on processing, and those things won't disappear at all. We just augment it with more. I think we need to wrap up, but thank you. If there's any more questions, we'll stay around as well.
Yeah, we'll be here. Thank you.